into the wild and wacky world of polynomials. As always, you want to make sure you hang on to these booklets. Unlike those of you whose booklets I saw in the recycling bin. That's, your choice entirely. But you do have a final exam at the end of this semester, and so having these booklets is probably, yes, I'm talking to you, yours was in the recycling bin. And it's still there because I never pulled it out. No, yep, Abdal. No, Dual. Yeah, you. This booklet for the last chapter, I found in the recycling bin. Yeah, you. And I left it there because that's your choice. I don't know if you're the one that put it there, but it was left here and someone tossed it. So, it could be useful to hang on to these. But again, you've got a final exam coming in February. You guys are Block A. Here we go. Polynomials. I hacked out a couple lessons here, so the lessons don't go in order. They go from lesson 1 to lesson 3, and the page numbering is going to be a little bit weird. I apologize for that. I didn't have time to fix it. And like I said, I took out a couple lessons because they use things we no longer do. So, polynomials. Those of you who hated letters, it doesn't get any better from here. Algebra is what we're going to look at here. Algebra. Sweet. Daria, on your way in, grab one of these things next to Zara. Daria is here. Love it. Daria, yeah. Oh. I'll move the whole stack. You need one of these. These, not what I'm right. There's 90 of them, and that's because I have 3 blocks of grade 9. So 3 times a maximum of 30 is 90. Here we go. Algebra is all about finding the unknown. Using symbols and mathematical operations. The thing that might bother you the most about where we're going here is that we're not actually going to be finding a lot of unknowns. We're just going to be manipulating expressions to combine terms and to multiply a lot of letters together. And then the finding of the unknown comes a little bit later. So when we talk about using symbols in math, you guys are typically used to what kind of symbols? Sorry? Oh, no, I don't. Oh, I don't mean the mathematical operations. So the operations, addition, subtraction, multiplication, division. There's these symbols, which I haven't shown you yet. There's powers. That's not the number 11. That's called an absolute value. These are the operations. When I talk about using symbols in math, you guys are typically used to what kinds of symbols? No, I don't mean operations. I mean, what kinds of symbols are we using these operations with? You all start, numbers are just symbols, right? This symbol has a meaning. We ascribe it a meaning. You're taught at a young age that this is the number 6. Does this represent 6 things? Only because we says it does. I mean, that symbol is fundamentally no different than this symbol. Could that symbol represent 6 things? Yeah, unless you're Roman, in which case this symbol represents how many things? 10 things. What does this symbol mean? That you're happy. Only because we say it does. 2 dots and a bracket that on its side like this. Does that have to mean happy? No. Well, I mean, we got this symbol too. That's just a semicolon and the capital letter P, but we ascribe it meaning. We say, okay, well, this is actually someone sticking their tongue out at you. So the symbols that we use day to day have meaning, and just like, what are you doing? You know what? Whatever. Figure it out. Just like we ascribe these symbols meaning, and you do stuff with this. You say this symbol plus this symbol is equal to this symbol. But even this is totally arbitrary. You're just the most comfortable using this. So we're going to introduce letters, but letters are going to behave similarly. So in this unit, we're going to use letters. We have all sorts of symbol options. Typically, the letters we use are English, but they don't have to be. Over the course of all of the math courses that I've taken, I've used the entire English alphabet, the entire Greek alphabet, a portion of the Hebrew alphabet, because you start running out of letters that mean things, because some of these letters have specific meanings. For example, the letter D means I'm looking for an unknown distance. The letter V means I'm looking for an unknown velocity. The letter T means I'm looking for an unknown time. The letter R means, like, all of these letters have some sort of meaning. Yeah, what's up?
Can I leave this with you to fill out?
Why didn't he bring it?
Because he was talking with me about
Sure.
this.
Okay.
So just the front.
Yeah, no, I've done one already.
Okay, and then are you going to give it back to...
I have to give it to him because he needs to fill it back.
He's going to fill out the black email.
Okay, well, I'll still give it to him and then he can hand it in.
Perfect, thanks.
Okay, so letters. Typically we use English, but there's all sorts. We use letters to represent an unknown value. And this is just a number we don't know yet. It's like a friend we haven't made yet. Some of you are like, I don't want to make friends with numbers. Well, too bad. You will. We'll make you make friends with numbers. So the value of the unknown can change depending on how we set it up. And so because of this, we call these letters that represent unknown values that can change, we call them variables. And now that's not a great color. Let's not use light green. Let's use dark green. And the most common variable you're used to using is probably the letter X. And then we start introducing other common ones from there. So the next most common one you were probably introduced to was Y. But there are 25 other, actually there's 24 other, nope, 24 total, 22 other good letters that we use for variables. There's 2 letters we try and avoid. Stop it, YouTube, please. 2 bad letters for variables are, Q's great, we love Q. You have a thought, Zara? No, but you put your hand up. T is good too. T stands for time. We like T. Though T can look like plus. It's a little fishy. The variable, the letter O, we try and stay away from the letter O. And the letter L. Because L looks a lot like 1, O looks a lot like 0. Unless you have special ways to write them. So, for example, let's talk about preparing pasta. For a person, you need 2 cups of dry pasta. I don't know if that's true. That seems like a lot. But, you know, maybe you really like your pasta. If for 2 people, you need 2 cups of dry pasta, how many for 2 people? 4. You just doubled it, right? If one person needs 2, then 2 needs 4. 3 needs 11's going to need, sorry, 22. What are we doing in this case? The amount of dry pasta you need is going to change for the number of people that you're serving, and we use these algebraic expressions all the time. An algebraic expression is a combination of numbers and letters to solve a problem like this. In this case, what could the expression be? It's going to be 2 times, we could use X, but what are we measuring? No, we're not measuring people. cups of pasta. So we need 2 cups per person. So maybe it is person we want to use. Maybe the letter P. P stands for the number of people. Or people, or the number, that stands for number, of people equals P. So then 2 times P would be the amount of pasta. I don't know. There's all sorts of ways we could set something like this up. So these expressions that we're going to create and we're going to learn how to manipulate are called polynomials. Now, polynomial is a compound word, just like percent was. Percent was a compound English-French word. Per 100. A polynomial is a compound word in Latin. Poly meaning. Does anyone know what that prefix poly means? You guys remember something called a polygon? What's a polygon? I would say Porygon for you Pokemon fans. It's a polygon. You don't remember what it means? Okay, well, poly means many. And nomial means term. So a polynomial is a many-termed object. It's an algebraic expression made up of many, question mark, terms. And how many is going to change. You could have 1, 2, 3, 7 terms. It's an unknown amount. When I say many, I mean if I said, you said, oh, there's many of them. How many? 1. Well, you might say that 1 isn't many, but this general term here, poly, can include 1 among the possible options of many things. Now, a term in math is a mathematical expression separated by addition and subtraction. So every time you see a plus or a minus, what you're doing is you're separating out a term. So if I had the number 15, for example, do you see any plus or minus signs there? No. So how many terms then are present here? You have 1. There is 1 term sitting right there. Or the letter X, how many terms do I have? 1. There's no addition. There's no subtraction. I've got 1 term there. If I take these 2 single terms and I add them together, now I've got a plus sign in there. I've got how many terms? I got 2 terms. If I take these 2 terms and I multiply them together, though, terms are separated by addition and subtraction. There is no addition or subtraction here, so how many terms do I have here now? I've got 1. So multiplying them is fine. Adding and subtracting them are how we represent the 2 separate pieces. So how many terms are here? There are 3 of them. How many terms are here? 2 of them. How many terms are here? And then the last one, 4. We can do all sorts of things to the objects in each term, but you only separate out terms when you see addition or subtraction. Now, we have special names for certain kinds of polynomials. If you have a 1-termed object or 1-termed expression, does anyone know the name for that kind of polynomial? We have prefixes that represent having 1 of something. If you don't know what sorry? You have a thought? You have a smirk on your face that looks like you have a thought. Okay, so what I mean by prefixes that denote how many of something we have, if I told you you were riding a 1-wheeled bicycle, what's that thing called? No. A tricycle has how many wheels? A tricycle has 3 because tri is a prefix that means there's 3 of something. Scarlett, you said? A unicycle. Or if you have the misfortune of having one eyebrow that grows together, we call that a unibrow because you have one of them. You have a single brow, or you have a single wheel on your bicycle. Now, that's not the only prefix that we have to represent one of something. If you have glasses, but you've only got the one lens to look pretentious, what's that thing called? With a chain, yeah, monocle. Mono means one. Uni also means one. And so we got to choose which of those prefixes we're going to use. It's not a uninomial. We use the prefix mono, and we shorten it, monomial. This is the prefix here, mono, because mono means one of something. So an example of a monomial would be something like, well, any of these things here. The number 15, the letter X, 15x, any of those things. It's a single term. Those are monomials. A two-termed object. Does anyone take a guess at the two-termed object? There's 2 different prefixes we use for 2 of something. What do you call a vehicle with 2 wheels? A 2-wheeled vehicle is a? This is a high-level question. 2-wheel, non-powered vehicle. It's not a scooter. A bicycle. Okay? A bicycle, for those of you who have never seen a bicycle, looks like this. There's your bicycle. Bicycle has 2 tires or 2 wheels. Bi means 2. So our special word for a 2-termed mathematical object is called a binomial. Someone give me an example of a 2-termed mathematical object. Sure, Hassan Joe, keep talking. 15 plus x. You betcha. And a 3-termed object is a trinomial. Tri means 3. Someone give me an example of a 3-termed object. A 3-termed mathematical object. Yes, a tricycle. You know what? Sure, I'll draw your tricycle. Let's do it. Let's draw a tricycle for Scarlett. Get this guy, and then you got a seat, get the handlebars, and it's going to go off into 2 wheels. That kind of supposed to be a tricycle. I'm really bad at drawing tricycles, apparently. Give me a mathematical object, three terms. German. I can see those gears moving inside your brain. The smoke's coming out of your ears. The gears are working so hard. That's a good thing. What is an example of a 3-termed mathematical object? So close. Sure, yeah, y. We like y. The reason that 5 plus x minus 2 isn't going to work is because we're going to talk about that on the next page, combining those terms. Maybe not on the next page. We're talking about it soon. So you want distinct objects. 5, x, and y are all different. So, and I separated them with addition, or German separated them with addition and subtraction. This is a totally acceptable example of a 3-termed or a trinomial mathematical object. And now the term polynomial is the catch-all term for everything. Everything, these first three, and anything with more than 3 terms. We don't have special names for anything beyond 3 terms. If you're ready, if you have no questions, flip the page. This class ends at 10:05, I think. Okay, so let's rattle these guys off. For each one of these, let's take a look. How many terms in this guy? 2. So it is a binomial. Love it. The next thing has 1, so we call it a monomial. The next one is 3 terms, so it's a trinomial. The fourth one is or how many terms are there? There are 2 terms because there's only 1 addition or subtraction sign. So that is a, binomial. That one down the second from the bottom is a, House and Joe, how many are there? There's 4, so yes, Aiken, we're going to call this thing a polynomial. We don't have a special name for anything above 3. And this guy is a only got 1 term. So that is a monomial. Cool. Questions, comments, concerns so far? Today's a lot of definitions. Okay, so we've talked about numbers of terms. Now there's going to be things about these terms we're going to talk about now. These terms have parts, and so some important definitions here to follow. We're going to talk about the degree of a term. Now this doesn't do a lot for you yet, but it's a concept that you need to know because as you move further in math, the degree is going to start to give us information about the mathematical object. Now, you're still a little ways from using that, but at this stage, all we need to do is identify what the degree is. Now, the degree of a term, of a single term, is the sum of all the exponents on, and I'm going to add a word in here, all, to really emphasize that. It's the sum of the exponents on all the variables in that term. Now your exponent laws test you just wrote for me. You were only allowed to add exponents together when the bases were the same. To find the degree, it does not matter what the bases are. You just take all of the exponents on any letter you have in the problem and you add them up, and that's the degree. So this guy only has one variable, and the exponent is a 2. Some of us struggled to identify that yesterday on the test. The exponent here is a 2. So that this term then has a degree of 2. That's it. What's the exponent on that guy? It's a 1. If there is no exponent written, the number is a 1. So then the degree here is 1. That is all. This guy, yes, Josh, is a degree of 2. Because we only care about the exponents on variables. This guy then is going to be, who said that? Zara. It's going to be 3. Because the exponent on the y is a 1. And to find the degree, you add them all up. 2 plus 1 is 3. Now, normally our exponent laws, we would say we don't do this. But for finding a degree, that's the technique. Term here is, or the degree here is going to be 5. And the degree here is going to be, is it 0 or 1? We want, so the degree is the sum of the exponents on the variables. Are there any variables? No, so then the degree is 0. You betcha. Cool. So that's the degree on a single term. Now we're going to talk about the degree of a polynomial. If you can find the degree of a term, then the degree of a polynomial is easy. The degree of a polynomial is the largest degree of all the terms in an expression. So to find the degree of the whole polynomial, you have to look at each term, figure out the degree of each piece, and then pick the biggest number. So let's do a couple examples. This term has a degree of, this term I'm pointing at right here has a degree of, there's no variables, it's 0. So this term right here, let's slow down maybe, phase on, up here. How many terms are here? 2 terms. Alex and Lola. I got 2 terms here. Are there any variables in the first term? No, so then the degree of just this term is 0. The degree of this term is 2. Scarlett, thank you. So which of those 2 numbers is bigger, 0 or 2? 2. So then the degree of the whole polynomial is the bigger of these 2 numbers. That's it. How about this one? This term is, let's look at each piece. How many terms are there first? How many terms? There's 3 of them. I'll ask you first, how many terms? 1, 2, 3. I have 3 objects separated by addition and subtraction. So then each one of these terms is going to have its own degree. This term has a degree of 2. This term has a degree of, this term has a degree of, so the biggest of those 3 numbers is, so that's the degree of the entire polynomial. Cool, next. How many terms here? There are 2 terms. I have 1 addition sign, a term here, and I got a term here. Now let's look at each piece. So let's identify this. There's a term and there's a term. The degree on this term is 2. Love it. The degree on this term is, how'd you get 5, Hassan Joe? Yeah, the y has an exponent of 1. When there's nothing written on the letter, it's a 1. So then 4 plus 1 is 5. And now I want to pick the bigger of those 2 numbers. The bigger number is, what is going on, you two? Are you sharing a single pencil? Then why do you keep grabbing his head? Take your phone. Well, you shouldn't have it. So you can keep his phone. Don't let him have it back until the end of the block. The bigger number there is 5. Okay. How many terms do I have in the last one? 3. I have this term, and that term. Let's look at the degree of each one, and then the degree of the whole polynomial. The degree here is 5. You betcha. The degree here is, the degree here is, so the biggest one is, done. Love it. Easy. Now you just need to remember it. There's 2 more definitions here. We're going to talk about coefficients and constants, and then I'm done. Coefficient is a word you should have heard before. What's a coefficient? We heard this term before? We should have. Scarlett, do you remember? It's just a word, a math word that's in your head somewhere because someone tried to teach it to you once and it's just bouncing around? Okay. How many of you feel that same way? It's in there somewhere, but we're not sure what it means. Okay, let's review. A coefficient is, what is going on? Just leave it there. Don't touch it. No, Faison, leave it there. That's, yep, leave it there. It's like the ring of power. It's trying to get away from you. A coefficient is the number we'll say it is the, there's a word that shouldn't be here. Let's scribble this out and the word and. Say it is the number in front of a variable. When we say in front can get kind of confusing. In front means multiplied. Sorry? Yep. It's the number multiplied in front of a variable. So, when there is no number written, what is the thing being multiplied by? What's the number that we say is there when there is no number written? It is a 1. So the coefficient on something like this would be a 1. And this thing only has one coefficient because there's only one term there. Every term has its own coefficient. So what are the coefficients listed here? If I look at just that term, the coefficient's a 2. And now let's look at this guy. With coefficients, you need to include the sign in front of the variable as well. So what is the coefficient on that x cubed there? It's not just minus, there has to be a number there too. It's -1, good. When there is no number, it's a 1, and you include the sign out front. So if this was addition, the coefficient would be +1. If it's now, because it's subtraction, the coefficient is -1. How about here? What are my coefficients on this guy? Yeah, this one is -1, and this one over here is +1. You betcha. How about this guy here? You know what? We're going to make this more interesting. I'm going to change the question. And I'm going to add another question. Add a box over here on the side. Because there's a type we haven't dealt with here. I'm going to say, I'm going to write this as 1/2 x plus 5. And then my last one over here, I'm going to have x divided by 3. I'll just leave it as x divided by 3. Why not? Is what that says. I'll zoom it in so it's easier to see. Now that's clear, right? Nice and clear. Okay, there we go. 1/2 x plus 5 and x divided by 3. Now, the coefficient is defined as the number multiplied in front of a variable. So there is no variable here. So there is no coefficient here, but there's a variable right there. What's the number being multiplied in front of the variable? 1/2. Fractions are numbers too, even though you hate them. A bunch of mathists. So the coefficient here is 1/2. And then the last one, x over 3. What am I doing with the x? Sorry? What's happening to the x mathematically? It's being divided by 3. But division by 3 is the same as multiplying by what? It's the same as multiplying by a third. Dividing by a whole number and multiplying by a fraction are the same thing. This is the same as, or it's equal to, 1 over 3 times x. These are the same. And so fractional coefficients are allowed, and dividing actually gives you a coefficient there too. So if you see this, x divided by 3, this thing is going to have a coefficient of 1 over 3. So fractional coefficients are allowed too. Yippee! You don't seem amused, Lola. Okay, and the last one, the last definition we're going to look at today before I set you to work is the constant. Constants are nice. They do not change. They are just there. A constant is the number with no variable, including whatever sign comes out front. So the constant in this expression is -2. The constant in this expression is nothing. What is the number that represents nothing? 0. There is no constant term here. The constant term is the number with no variable. Each one of these things has a variable. So we say the constant is 0. There isn't one. Daria, put your phone away. Constant here is 7. And the constant here is -1. Comments, questions, concerns about anything I've done there? There's lots of giggling about a whole assortment of things. I want to see what time this block is done. 9:55. Perfect. You should be able to get this done in those 8 minutes. There it is. This is your homework. 1 page. That is all. And you can totally get that done in the next 8 minutes. On your mark and set, go.